Hello everyone. In this video I will talk about semantic search. So the meaning of semantic search is similarity search. Let's take example of e-commerce system where we use keyword search. Suppose there is this e-commerce database where we have these products. If somebody searches for iPhone, we do a keyword search and fetch iPhones. But in LLM, we don't search for the exact term, like we are not searching for chest pain. Somebody will ask a question and they will expect answer for that question. So question would be, I'm feeling heavy, my chest is heavy, and they are looking for the answer. So how to search an answer for a question? So that will need a related search. Like if I say chest is heavy, then this LLM need to find what happens, what is related to chest heaviness. So all the terms which talk about that, which might talk about the solution when chest is heavy. But what if LLM has data like chest pain, but somebody is saying heavy chest? So in that case, how it would answer it? Right, so this kind of keyword search, exact match, or even fuzzy search where some part of the text is searched will not work in this case. Right, even in Google search they have implemented semantic search. They don't just do a keyword search, they do a similarity search. And nowadays if you see in e-commerce also, suppose you are looking for iPhone, they will also show you other related phones, right? Because nowadays they are also implementing semantic search. So in e-commerce or Google search or in LLM, inside their system they have implemented semantic search. So chest heavy will be searched inside LLM and they will find all the related terms, similar search. Like chest heavy means chest pain, and then they will search for answer for chest pain. So LLM inside has implemented semantic search. When we ask question, they do semantic search inside because they have a lot of data. They cannot do just the keyword search. So inside LLM they do semantic search. And when LLM does not find the data in its own memory, its own knowledge base, it uses the search tool, and that search tool searches the internet. That internet search does a semantic search. Based on the question, they do a semantic search, and from the internet data, they fetch a fixed number of results based on the semantic search, and they give it to the LLM. And if we are implementing RAG, similar semantic search we have to implement inside our system. So one semantic search is implemented inside LLM, one is done by the search engines, and here in RAG the third one we have to do inside our own system. Okay, that semantic search we have to implement and we have to attach that result to the LLM. LLM does not do the search. We search it, give the data, and then it uses it. So semantic search is implemented in various steps. So to do a similarity search, suppose we have iPhone and we want to do a keyword search, we just match the text, okay, exact match or fuzzy match. Somehow we do a string match. But in semantic search, we need to do a match meaning search, similarity search. If we are searching for iPhone, we need to uh, also fetch pixel because it's related. Okay, it's related to this iPhone term, or the meaning of iPhone is what? It's a phone. So we do all phone related search. When we say we are feeling heavy chest, so the meaning is we are feeling chest pain. So we find everything related to chest pain. So how we do that? Right here, if in semantic search, suppose we have private data in heart attack, we face chest pain. This is one of the study mentioned in the private data, and the question is heavy chest. So how this will match? Heavy chest pain, or sometimes even chest will not be used. Heavy, or we say breathlessness. When we feel chest pain, we feel breathlessness. So I will say breathlessness. Then breathlessness needs to map to chest pain. And for chest pain, what is the result? We need to display. So how this search will find this document? That is by semantic search, okay? Meaning search. So how that is done? That is done using a concept called vectorization. So normally in keyword search, we do a string match. String to string is matched. For semantic search, we do a vector match. We convert the strings into vectors. So this breathlessness is converted into some vector format. And vector format are in number 1, 2, comma 45, comma this, comma that. This is a number array of numbers. And in this database, we also don't store the string. We convert this data into vector, and then vector data is stored in this database. So this whole string is converted into string array of numbers. Okay, so this is vector representation of this string. So instead of normal database, we use a vector database. So when we get the document which is in string, we convert that to vector and then store in the vector database instead of a normal database. And when a query comes, we convert it into vector, and then we do a vector matching. Like in string match, we compare iPhone equal to iPhone. So here we do a vector matching. And vectorization is a concept. It's an engineering concept where all the related vectors are stored together. I mean, there are some principles, we can study that in later. When related terms are vectorized, they produce similar vector. Okay, so here we don't have breathlessness, here we don't have chest pain, but somehow these are similar meaning. Breathlessness meaning chest pain. So somehow when we convert these into vectors, these values match. And when we search, this match is true. And then we fetch this document. So for now, just assume, just understand that when we convert a string to vector, similar meaning strings get matching vector value, and that's why when we do a vector match, we found a match. When we do a vector search, we find a match. So breathlessness is not equal to this string, but its vector form and its vector form are similar. So when we do a vector search, they match. So all the documents which are related to breathlessness get similar vector, and they are stored together, and when we do a query with vector, they are retrieved. So this is how semantic search works. So semantic search is a concept where we do a meaning search where two terms are related, but how it is implemented is using vectorization. So what we do when we have to implement semantic search is two steps. First, we have to prepare the data and then retrieval. Prepare data and then search. So how to prepare the data? So normally when we get the data, suppose document or something, we just store in the database. But in semantic search, we get the data, we convert that into vector and store in a vector database. Okay, so this way we do the preparation. So when we implement a RAG system, that is one of the main important step. Whenever we collect the information, we first have to convert that into vector and store in the vector database. So what happens? We have to create a pipeline. First somebody prepares a document or collect the information from somewhere. They store it in a normal database. Then that normal database trigger a method which converts them into vector, and then vector values are stored in the vector database. And when somebody queries, that query, that question is also converted into vector, and then vector search is done in that vector database, and then we get the results, and then the results is sent to the LLM. Same thing is implemented the LLM. When we query, we send it to LLM directly, but LLM converts that into vector and its own data is into vector, so they do a semantic search. When it searches on the internet, it sends that query to the search tool, it converts it into the vector, and that search engine has the data in vector form, they match and they return. So same way we have to vectorize our own data, store in the vector database, and when the search comes, we have to convert that into vector, search it and return the data to LLM. So this way we will be able to return a relevant document. So when we search for iPhone, we return pixel also. When we say breathlessness, we return all the documents related to chest pain. And then LLM use that document to produce better results. So RAG requires semantic search. Semantic search is implemented using vectorization. Now how to convert the string data to vectorization, to vectors? So there is a process, vectorization process, where we use a library which takes this string, do some calculation and returns the data in the vector format. And as in encryption, where we use same algorithm, same key for decryption, here also we have to use the same library to convert this question to this M vector so that it matches. Different library could produce different vectors. Now in the normal case we can use normal simple vectorization libraries, but in case of AI, where AI does the matching and searching, that vectorization library is a AI model, LLM model. Instead of a static library, here also we use AI. We send this data to LLM model and LLM model converts that into vector. So like in OpenAI we have general LLM model, we have embeddings model. So when we do this vectorization, that is done by embedding models. So we implement a LLM layer here also. When we get the data, we send it to LLM, but embedding LLMs. And this embedding LLM converts this data to vector format. And same way, the same model is used here to convert the query to the vector. So when we implement RAG, first we have to implement this part, data preparation part, where we implement this pipeline in which data comes, it's sent to the LLM model, embedding model, it converts that into vector and we store in the vector database. So here we need vector database. And then we implement search, where we get the query, we convert that to vector using the same process, and then that query is sent to the search, and that search is done, vector matching is done. One more part is when we query in this data, we could get, suppose it's a big private repository, for a term we can get thousands of records. If it's a big medical repository, for one term breathlessness we could get millions of records, thousands of records. Okay, suppose this whole data is 1 billion articles or 1 billion sections, 1 billion documents. When we search breathlessness, we get 1 million results. We cannot send that 1 million record to LLM. We need to select some relevant document most relevant document from that result. So for that we use two process. One is called chunking and one is called re-ranking. When we get this result, we do chunking. We split that data and we select some of the chunks, and then we send it to re-ranking algorithm to find the most relevant document, and then select the top most relevant and then send it to LLM. Okay, so for now just understand this concept. Semantic search is similarity search, where we search based on the meaning, not exact search string. For that we need to convert the data into vector. That vector conversion is done using some library. In case of AI we use AI LLM model. So we convert the string into vector using embedding models. We save that into the vector database. We do the same for query, and when we get the results, again we do two steps, that is chunking and re-ranking. And after all this we get the final most relevant data which we send to LLM. Okay, so this is the concept of RAG. In the next video I will show you a proper demo with code how to do all these steps. If you have any doubt in this concept, you can ask.